All right, hey Algebra 2. Today we're going to work on some inequalities, both regular, just linear inequalities, and then some absolute value inequalities as well. So the difference here in an equation and what we're doing today, as you'll see, is that instead of an equal sign, we're going to be working with an inequality symbol. So when we finish our answer is not just going to be one number, but it's going to be something like x is greater than 5, which would mean that our x value could be anything bigger than 5, okay? So we solve inequalities pretty much the same way that we do equations. The one thing that we have to be careful of is if we divide or multiply by a negative number, you have to flip the inequality. Okay, so we're going to see that several times today, but we will get there eventually. Okay, so I'm looking at this first one. It says 6x minus 10 is, and then this symbol reads greater than negative 22. Okay, as a reminder, if your inequality is open to the left, that's a greater than. Okay, if your inequality is open to the right, that's a less than. I always like to remember that if it looks kind of like an L, that's a less than. Okay, so first thing I'm going to do to get x by itself is add 10 to get rid of this minus 10 to both sides of our equation. So I get 6x is greater than, and then negative 22 plus 10 is negative 12. Okay, x is still not alone, so I'm going to divide by 6 because the 6 is multiplying here, so we're going to divide. And we get x is greater than negative 2. I did not have to flip my inequality because I divided by a positive 6. Okay, so here's my answer. So what this is saying is that my x value could be any number bigger than negative 2. We're going to show this on a number line. Okay, so I'm going to put a couple marks on my number line. I don't really care how many numbers you show on there, as long as you make sure you show the number negative 2. So I'll put negative 2 here. This would be negative 1, negative 3, negative 4. And if I want to be greater than negative 2, I'm going to put an open circle at negative 2 because I don't have an equal to on this inequality. And then greater than would be headed towards the right. So I'm going to show that I could take any value greater than negative 2. Okay. All right, same idea on the next one. It says negative x divided by 3 is greater than or equal to 5. Okay, I read this line as divided by, so the opposite of dividing by 3 is going to be multiplying by 3. So I'm going to multiply both sides of my inequality by 3. That's going to undo the dividing by 3, so that leaves me with negative x is greater than or equal to 15, because 5 times 3 is 15. Okay, x is still not alone because it's got this negative in front of it, which is like a negative 1. So I'm going to divide by negative 1. And I'm going to go, oh, I divided by a negative, so I need to flip my sign. So now this is going to say x is less than or equal to, and then 15 divided by negative 1 is negative 15. Okay, we got x by itself, and so now we just need to graph that solution on a number line, making sure that I show negative 15. So maybe I put a negative 14, a negative 13, and then over here maybe a negative 16, a negative 17. Less than or equal to. So the equal to tells me I'm going to fill in my dot at negative 15. And then less than tells me that I want my arrow to go to the smaller numbers, or in other words, to the left. All right, good so far? Okay, the next two are a little bit different. This one right here says that m minus 7 is greater than negative 3, or negative 2m plus 1 is greater than 1. In other words, I have two different inequalities that I have to graph on the same solution set. Okay, They're part of the same situation and they're referring to the same variable. So I'm going to work on m minus 7 is greater than negative 3 first. Okay, this one's pretty straightforward. We need to get m by itself, so we're just going to add 7 to both sides. I get m is greater than, and negative 3 plus 7 is positive 4. Okay, and then I'm going to come over here and work on this inequality. Negative 2m plus 1 is greater than 1. I'm going to subtract 1 first. I get negative 2m is greater than 1 minus 1 is 0. And then I'm going to divide by negative 2. Hopefully you have sirens going off in your head saying, oh, she said divide by a negative, so we need to flip our sign. M is less than, and then 0 divided by negative 2 is still 0. So we've got our two answers. We've got m is greater than 4 or m is less than 0. Okay? When I go to graph my number line, I need to make sure that I am able to show the value 4 and the value 0. I'm probably going to, I'm going to put 0 right here. I'm going to count by 2s this time. It just makes more sense. Okay. Again, as long as I can see the numbers 0 and 4, I'm good. So I'm going to graph m is greater than 4 first. Greater than without an equal to means open circle, and then greater than goes to the right. So m is greater than 4. Okay. And then I'm going to graph m is less than 0. Again, no equal to, so I've got the open circle, and then less than goes to the left. Okay. So the value for m could be any number bigger than 4, or it could be any number smaller than 0. Okay. All right. This next one is what we call a compound inequality, where we have two different criteria and our y value is kind of stuck in between those two. Okay. So I'm going to solve this all at once. When I add 3 in the middle, because I'm trying to get this y by itself, I have to add 3 on both of the outer sides of the inequality to keep everything the same. Okay, so now I have negative 6 is less than or equal to 4y, which is less than or equal to 16. And then I'm going to divide by 4. And again, I've got to do it on all 3 parts of my inequality. So negative 6 divided by 4, we could simplify that to negative 3 over 2, or we could write it as a decimal, which might be a little bit easier for us when we get to our graph. Negative 1.5 is less than or equal to y, which is less than or equal to 4, because 16 divided by 4 is 4. Hopefully, you're looking at this going, oh, that looks kind of like the domains and ranges that we've done in inequality notation. Okay, and you're right, it does. And what this notation is saying is that y has to fall somewhere between negative 1.5 and 4. So I'm going to draw my number line. Let's see, I'll start at 1, 2, 3, 4. You can squeeze a 5 on there. Okay, so I want to go to negative 1.5. I've got the equal to on here, so I'm going to put a filled in circle. Oh my goodness, that is wrong. That is not negative 1.5. That is positive 1.5. Let's try this again. I'm going to extend my number line. 0, negative 1, negative 2. That's better. Forget that guy. Negative 1.5 is right here. So sorry. Okay, and then all the way to 4, which is right here, again filled in. And then y needs to be between them. So we need to draw our line between those two values. Okay. All right. In example 2, we are taking a sentence and writing it as an inequality. We don't need to solve it. We don't need to graph it. We're just trying to go from words to symbols. Okay. So we're going to look at some vocab here. We have 9 less than. When we see 9 less than, we should think subtracting. The quotient, ooh, that's quite a big math word. Quotient is answer of a division problem. So when we see quotient, we're thinking of dividing. And then when we see a number, this means I don't know what that number is. Or in other words, it's a variable. It's an unknown. We're typically going to use x there. Okay, so the quotient of a number and 2, this is the number 2, is less than. Is less than, that's the less than symbol. Okay, so what I've heard so far is that we're doing some sort of dividing. And what we're dividing is a number, or in other words, something I don't know, and 2. But I don't just want to do the division right here. I want to do 9 less than that. So I want to subtract 9 from whatever that division is. And then I need all of this to be less than 10. And that's all we have to do is take the sentence and write it in symbols. Okay? All right, let's read through the next one. 6 times means multiply, a number. Remember, a number means we're going to use a variable there, probably x, is at most 11. Is at most. Interesting words here. Is at most. So if something is at most 11, that means that the biggest value it could be is 11. But it could also be something smaller than 11. So what I'm hearing is that if it's at most 11, then that means that it's less than or equal to 11. And then this wording here, 6 times a number, just means 6 times x, or in other words, we write that as 6x. Okay? All right, now this bottom one, there's a lot of words here. The difference of, difference means subtraction. Difference of a product. Now, product means multiply. I'm going to write those out. Difference is subtract. Product is multiply. So we've got 2 different things going on. We need to figure out how to do those at the same time. The difference of a product of 5 and a number. The product of 5 and a number means we're multiplying 5 times x, or in other words, 5x. That's 5 and a number. So the difference of a product of 5 and a number and 2. I think the difference is referring to the 5 and a number and 2. So I think this means 5x minus 2 is at least 10. Okay, if I say that something is at least 10, then it's either 10 or it's more. So we would say is at least means greater than or equal to 10. All right. Okay, let's flip the page and do a couple inequalities. Okay, so when we graph or when we solve these inequalities, we do them a lot like we did the inequality equations. Or sorry, oh my goodness, absolute value. When we solve absolute value inequalities, we do it a lot like we did with the absolute value equations, where we make two separate inequalities, okay? The first one stays exactly the same. X is less than 6. And then the second one makes whatever's in the absolute value negative. Negative x is less than 6. And since this one was just an x, I really don't need the parentheses here. Usually there's more than just an x in there, which is why we use parentheses. Okay, this first one is already solved, which is super nice. X is less than 6. We'll go graph that on this number line here in just a second. This second one is not already solved because x is not alone. So I'm going to divide by -1 to get rid of the negative here. And now I have x is, I divided by a negative, so I've got to remember to graph, or to flip my inequality, greater than -6. Okay, so I've got these two things to graph on my number line, and then we're going to do one additional thing to kind of write our answer a better way. So I'm just going to put these two numbers on the number line because truthfully, I don't care about anything else. So I'm going to put -6 on the left side and +6 on the right side because that's where they would fall on the number line. And I'm going to go, okay, x is less than 6, open circle at 6, my line's going to head towards the left, and x is greater than -6. Again, open circle at -6, and greater than, my line's going to head to the right. So what we see on this one is that our inequality should really be written as like a compound inequality, like we saw on this one right here, okay? Where the y, or in this case it would be x, was written between the two numbers because your graph was shaded in between the two, okay? So we call this an AND solution because your shading is between two numbers. So what we're saying is that x has to be greater than -6 and it has to be less than +6. Okay, so we're going to write our solution with x in the middle and then the lower boundary on the left and the upper boundary on the right. So -6 to +6, just like this. Okay, the other way that we could write this is like a domain, an interval notation. So we could say parenthesis, because it's not a filled-in circle, -6 to 6, parenthesis. Okay, either of these is totally fine with me. All right. Okay, why don't you pause this video and try the next one and see how it goes. Okay, so I created my two inequalities. X is greater than 4, just leaving it exactly the same, and then -x is greater than 4. Then I solved this one by dividing by 1 and flipping my inequality. So I get x is less than -4. When I go to graph this one, I'm going to go, okay, x has to be greater than 4. Open circle, because there's no equal to. Greater than goes to the right. Okay. X is less than -4. Again, open circle. Less than goes to the left. So this is definitely not an AND solution because my shading is not meeting in the middle. It's not meeting between two numbers. It's headed out, away from each other. So this is what we call an OR solution. Okay? So the way that we can write this is we can just write these two separate pieces. We can say x is less than -4 or x is greater than +4. All right, that's great. If it's an or, you're welcome to write it like that. The other thing that we could do is we could do this again like a domain, and we could say negative infinity to negative 4. And then the word or, we would use this kind of U symbol to say that we have two pieces that we're putting together. And then 4 to positive infinity. So if you like that better, you're welcome to write it like that. Okay. Okay. Next one. Absolute value 3x plus 5 is greater than or equal to 14. There's nothing outside the absolute value. So I'm just going to go ahead and start by splitting into my two inequalities. 3x plus 5 is greater than or equal to 14. Everything stays exactly the same. And then negative 3x plus 5 is greater than or equal to 14. Okay, I'm going to subtract 5. 3x is greater than or equal to 9. Divide by 3. X is greater than or equal to 3. I'm going to distribute my negative. Negative 3x minus 5 is greater than or equal to 14. I'm going to add 5. I'm going to get negative 3x is greater than or equal to 19. And then I'm going to divide by negative 3. Dividing by a negative. X is less than or equal to, and then 19 divided by negative 3 is a little bit bigger than negative 6, negative 6.333. Okay. So I'm going to put those two on my number line and figure out if it's an and, where we put x between the two numbers, or if it's an or, where we write the two sections separately. Okay. So here's negative 6.333, hypothetically, and here's positive 3. So x is greater than or equal to positive 3. Filled in circle because of the equal to. Greater than goes to the right. So I'm starting to think this is probably an or. But let's just make sure. X is less than or equal to negative 6.33. Filled in circle because of the equal to. Less than goes to the left. So yes, indeed, this is an or type of solution. Okay. So we can say x is less than or equal to negative 6.333, or x is greater than or equal to 3. Okay, the other thing that we could say is, well, we had a section from negative infinity to negative 6.333. That gets a bracket because of the filled in circle. And it also had a section from bracket 3 to positive infinity. If you like that better, because we're getting good at interval notation, you're welcome to do your answer like that. Okay. Okay, last one. I'm going to start by getting my absolute value by itself, because I can't do anything else until this part of my inequality is alone. So I'm going to add 8, and I'm going to work kind of on the left side of my page over here. I get 6, absolute value of 4p plus 2 is less than 42, because I added 8. Absolute value is still not alone. It's got this 6 out in front that's multiplying, so we're going to divide by 6. Absolute value of 4p plus 2 is less than 7. All right, now I'm going to split and make my two inequalities. 4p plus 2 is less than 7. everything stay the same, and then make it negative. Negative 4p plus 2 is less than 7. Okay, so I'm going to subtract 2. 4p is less than 5. And then I'm going to divide by 4. P is less than 5 divided by 4 is 1.25. Okay. Hopefully you're using your calculator if you need it on those. I'm going to distribute my negative here. Negative 4p minus 2 is less than 7. I'm going to add 2. Negative 4p is less than 9. And then I'm going to divide by negative 4. I divided by a negative, so I'm going to flip my sign. P is greater than, and 9 divided by negative 4 is negative 2.25. So let's go put those two numbers on our number line. Negative 2.25 is the smaller one, and positive 1.25 is the larger one, so it goes on the right. And then I'm going to go, okay, let's do less than 1.25. So open circle for 1.25, and if I'm going less, I'm going to the left. So it's starting to look like it's probably an and, since we're headed towards the other number. P is greater than negative 2.25. Open circle for negative 2.25, and then greater than heads to the right. So this is an and. Our shading met up in the middle. So we can put P right between our two numbers. Negative 2.25 is the lower one, and 1.25 is the higher one. Okay, or if we want to write it like a domain as an interval, we would use parentheses because of the open circles, negative 2.25 to positive 1.25. All right, let me know if you need more help.